All right, ladies and gentlemen. Question number one begins with a small high school has 60 students in their senior class. Of these seniors, so that 60 students becomes our total. Of these seniors, 20 complete in the school rodeo, 15 complete in a school band, and 5 do both. They've just given me enough information to create a Venn diagram. They've given me event A, event B, the overlap, A intersects B. It's very important that you note that A, B, and A intersection B doesn't capture everyone. There are those people who don't compete in either the rodeo or the school band. So Alex asked, do we have to create a Venn diagram? No, you don't have to create a Venn diagram. However, I think a Venn diagram is the most helpful way to answer the question. Questions on number one. Next problem. Without even doing anything, I notice that I see a lot of binomial notation. So right away, but this is binomial, these two could potentially be binomial if, depending on what pieces get eliminated. So now I'm going to go in with the mindset that this may be a binomial problem. A student takes a 20-question multiple choice test. Okay, right away I'm thinking multiple choice, you're either right or you're wrong, and answers every question by random guessing. So there's independence, he doesn't know what he's doing. And if each question has 5 choices, what is the probability of answering at least one question correctly? Okay, so at least one question correctly means one or more. So the helpful hint today that I gave you was I'm going to write out all the possibilities. N is going to be 20. 20 questions. K is going to be 1 or more. So 1, 2, 3, ... all the way up to 20. And the probability of success on any one trial, they tell me is, well, they don't tell me, do they? Do they tell me? Oh, 5 choices. So if 1 is correct out of the 5, my probability of success on any one question is 0.2. So right away, my mind goes to a normal CDF where I'm going to write out, I have 20. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I want to know the probability of getting 1 or more correct. At least 1. That means 1 or 2 or 3. It means everything except what? 0. So it's the complement, the 1 minus the probability of getting none correct. It's going to be a complement of exactly 0 correct. And I'm not going to give you any more help. You have your formula. It's on the formula sheet. If you forget it, go from there. A coin is tossed 3 times. What is the probability that it lands on heads exactly 1 time? All right, so this is definitely binomial because tossing coins, they want to know exactly. There's independence. What happens on one coin flip doesn't matter on the next. But you know what? I can't really think about how to set this up binomially, so I'm just going to go 3 coin flips is super easy. First head is a head or a tail. Second coin flip, doesn't matter what I get, the next one can be a head or a tail. So forth and so on. That's 1 flip. This is the second flip. I would need to do that again for the third flip, and then I'll be able to answer my question really easily. You also have the option of doing binomial if you choose. Next problem. A card is drawn at random from a deck of ordinary playing cards. You win $10 if the card is a spade or an 8. What is the probability that you win? Okay, so they give me this $10, which normally would factor into an expected result, but they're not asking me about my expected winnings. They're not asking me about my expected outcome. They're asking me a probability. So that $10 is actually superfluous information. Okay, it's thrown in there because normally, or a lot of times, they will ask me, what's your expected winning? And that $10 would factor into that. But since they're simply asking what's the probability of winning, that $10 has nothing to do with whether I win or whether I lose. It just tells me how much I'll win if I win. So So the probability comes down to what's the probability of getting a spade or an eighth. What I need to determine. A in this case is a spade, and then B in this case is getting an eighth. So it's going to be an addition formula because it's A or B, A union B, which remember, it's the addition rule, but I need to know if they're mutually exclusive. So the first thing I need to decide is the probability, can a card be both an ace and a spade? And if it can be, then I need to subtract out that overlap. So it'll be the probability of A plus the probability of B minus the probability that it intersects A and B, which in this case would be both an ace and a spade at the same time. Mark? No, that definitely isn't. It's not minus 1. Next question. If you get this one wrong, don't come to class tomorrow. Anybody. This comes back to the very basic definition of probability. All of our probabilities need to add up to 1. So if we add this, and we add this, and we add this unknown, it will total 1. Simple algebra is necessary. Suppose a die is tossed 5 times. What is the probability of getting exactly 2 fours? Again, another binomial probability. Okay? That's all I'm going to give you as a hint. It's a binomial. They say exactly, so would that be a PDF or a CDF? It's going to be a PDF. I need to identify what N is. I need to identify what P is. I need to identify what K is. N is the number of trials. P is the probability of success. K is the number of successes that I'm looking for, and I will have my answer. Next, Bob is a high school basketball player. He is a 70% free throw shooter. So that means that he'll either make it or he'll miss it. So it's 50-50, right? No, thank you. I can't say it enough. No, it's not just because he makes it or he misses it 50-50. He makes it 70% of the time. That means his probability of making a free throw is 0.7. What is the probability that Bob makes his first free throw on his 5th shot? This is not binomial because they're not setting the number of trials. They haven't told me how many trials. This is geometric because we want to know what's the probability that it's going to take 5 trials before we have it. So this is a geometric distribution. That's my only hint for in your book. A box contains 3 yellow, 2 red, 4 green, and 2 blue marbles. 2 marbles are taken one after the other. What is the probability that both marbles are red? The only hint here is that we're not using replacement. So our second probability will be conditional based on what happens in the first one. So when we do that second probability, the first probability is the easy one. The second one, we just have to remember we take into account that we are looking at the probability that the second one is red, given that the first marble we pulled out was red. Okay? We have to remember that that second probability is going to change based on what happens in the first instance. And the last question for today. Are we good? Yeah? I thought you said hold on. Oh, you said it. Okay. 4 children are asked to pick their favorite ice cream flavor out of 8 different flavors. Each of them is equally likely to pick any of the 8 ice cream flavors. What is the probability that each child orders a different ice cream flavor? Well, I'm going to begin by defining my four events. I have four events. I have child A picking an ice cream, child B picking an ice cream, child C, and D. The only issue is that after child A makes a pick, child B, we don't want him to pick any flavor. We want him to pick any flavor but what child A picked. Because they want, what is it called? Each child orders a different ice cream. So that only happens if this is not a binomial. This is not binomial. This seems like quite a complicated problem until you boil it down to defining each of your events. Once you define each of your events, the probabilities are very easy to identify. And after you've identified those four probabilities, all you're going to do is multiply them to get the overall probability that events A, B, C, and D happen together. Yeah. So A is just, kid A gets to pick any flavor. Kid B gets to pick any flavor but the flavor that kid A picked. Kid C gets to pick any flavor except for what B picked and what A picked. And those are going to be different because we defined them to be different. And kid D gets to pick, he gets the worst luck. He gets to pick anything except what kid picked C picked, what kid B picked, and what kid A picked. So he will have the least amount of change. That concludes the hints for today. Hope you enjoyed my tips.